Hi, welcome back to our video lecture. So here's another example regarding the integration by parts. Say we have e to the x sine x d of x. Once again, our technique is to assign which is u and which is our dv. So we have ex and sine ex. Both are integrable, but uh, let's try to use our e to the x as our dv in sine x in our u. So by this, our du, or the derivative of u, is just u, and derivative of our sine x is just cosine x dx. And for our integral of our dv, we have v, then the e to the x d of x is just e to dx. Okay. So from here, according to our formula, the e to the x sine x d of x is just equal to u, which is sine x, and then v e to the x, then minus the integral of v e to the x, and then u du is cosine x d of x. Okay. So as you can see here, our dv du is almost exactly the same on our original integral, but in this time we have e to the x multiplied by cosine x, but our original equation is e to the x multiplied by sine x dx. Okay, so this is I mean it seems like they are in same difficulty in integrating this kind of integral as our original integral. So it is not more complex, but they are in a somewhat similar condition from our original equation. So let's try again to integrate this part using our integration by parts. So let's assign once again our u. So by this time, our u, let's make it as cosine x. Then our dv is the same to the x d of x. Okay. So our du here is the derivative of cosine x is just negative sine x, right? Sine x dx. And the integral of this is just the same, right? This one. So we have e to the x. And then we have perform again the integration by parts in this integral. So we have, let's copy this one. So we have sine x e to the x. Let me copy also this original integrand here. Then minus the integral of cosine x dx is just equal to the u v minus the integral of v du. Yan. So simplifying this, we have e to the x sine x minus, let's distribute the negative sign, we have negative e to the x cosine x, then negative times negative, we have positive the integral of e to the x. This one is, we have negative 1, so we have negative times negative, we have positive, and negative times positive here. This one is positive. So we have, this is negative Yan, this is negative. Okay, so we have e to the x sine of x dx, and our original is also e to the x sine of x d of x. Okay, so as you can see here, if you would notice, our original e to the x sine x dx is also equal to this part, e to the x sine x dx. And let's try to move this part on the left side of our equation. So we have the integral of e to the x sine x dx. Then this will become positive, so we have positive integral of e to the x sine x d of x is equal to this term. We have e to the x sine x minus e to the x cosine x. Alright, so from here we can now add these two same integrand here. So we have 2 integral of e to the x sine of x dx is equal to this term, e to the x sine x minus e to the x cosine x. Okay, but based from our original integrand, we need the answer for a e to the x sine of x dx 1, only 1 e to the x sine of x dx. But here in our simplified solution, we have 2 e to the x sine x dx, so we only need 1, so we need to divide this by 2 as well as this. Okay, so we've left here with e to the x sine x dx is equal to this whole term here. So we have e to the x sine of x minus e to the x cosine x all over 2, and this is now our final answer. Okay. Let's review once again. So our problem is that we have e to the x sine x dx, and using the integration by parts, we need to assign du and the dv, and we've chose that u is equal to sine of x and dv is e to the x dx. So we've got the derivative of u and the integral of dv, and then we apply the formula, which is this can be also written as uv minus integral of v du. And as you can see here, it is suggested, right, diba, that dv du must not be more complex than our original integrand. So, but as you can see here, they are somewhat similar, except that this is in terms of cosine and this is in terms of sine. So by that, we've tried to once again perform the integration by parts, and by letting once again our u as cosine x and our dv as e to the x dx, and then we perform the derivative and the integral. Then we perform once again the integration by parts to solve this integral here. So by copying all our answers, we have the original integral. So we have the answer here. We have copied that, and then we perform the integration by parts here. So using the integration by parts, we have u v, wherein our u now is cosine x and our v now is still the e to the x, and then plus dv du, wherein we have e to the x multiplied by negative sine x d of x. And since we have a negative and negative sign here, then it will become positive. And by doing that, we've simplified it further by distributing the negative sign here. That's why we have come up with negative e to the x cosine x and negative integral of e to the x sine x. And we've noticed that our original integrand is also the same with this last part of our solution here. So we've combined these two on the left side. That's why we've come up with the because this will become positive, so we have 1 e to the x sine x dx and 1 e to the x sine x dx here. So we've come up with 2 e to the x sine x dx. And then we equate it with our answer, and then divide both sides by 2 because we only need to know the integral of 1 e to the x sine x dx. That's why our final answer is this one. Okay, thank you so much.